Okay. Okay, you can just maybe try and see these three questions. I believe number two, you should have not a problem, right? For number two, first you do the cross product and then just integral. I think the integral also not really having complicated equations, right? For number two. Okay, maybe I can start with number two, and then uh, we can follow up the other question as well. So we can start with taking it to cross product. This is the equations, and we may have the we can directly write three, and then we have we start from t. Maybe start from I. Oh, no, it's k. Okay. Okay. Minus k. 1, 2, 3, 3. Yeah. You can write that this is 3t minus 2et I, and then minus 3 minus 2t, or if you want to make it flat, so 2t minus 3, right? And then plus j, and then plus et minus t squared. Okay, right? Okay. Or you can write into another method that you can also get done. You can take this and add, and then minus this, right? We can also make it into, so 3ti plus 2tj plus etk minus t squared k plus 2eti plus 3j. And I think this is supposed to be the same, right? Three t minus 2eti plus 2t minus 3j, right? Same. And plus et minus t squared. Okay. And then we can just integrate, right? Integrate all. So integrate with respect to t. For the integrations from 0, 1 cross VT is to integrate this. Or maybe let me write 1 by 1, 0, 1, 3t. Let me write into a bracket. I think it's better to write in a bracket. And then this will be 3 over 2 squared minus 2et. And the results will be 3 over 2, 0, minus 2, minus 2 over 2, 7 over 2, minus 2e, negative 2, e minus 1 over 3, 1 minus minus 1 is 4 over 3. That's the answer. So this is number 2. I believe it's supposed to be not too difficult, right? Okay. The number 3, anyone has calculate number 3? It's implicit, using implicit function of two variables. You are using the implicit derivative or differentiations. You can write the answer and at the chat box. I'll be giving you a few minutes. Okay. Anyone? Is there anyone solving number 3 or 4? Maybe number 3? Anyone got the answer? Yeah, number 3. You can write using the directly implicit. Okay. Just as in calculus 1 implicit, or you can write through the formulations that I believe I already mentioned, that if we have this dou z dou x, okay, you can have the minus partial and then okay, and we can let the function as this one, right? Or you can just directly take implicit. I think still okay, not really that complicated. But if you want to maybe simplify your answer, you can also use this one. So you can let functions, yes, 1 over 3 minus 1 over 3. So we can have this, okay? Sorry. We can have using this, or we can directly take implicit from here. So if you would like to take from here, then we can look out the partial x. Okay, 1 by partial x is 2xz, right? 2xz squared, and then minus yz e xyz. Oh, y. I'm writing y here. Should be z. And then fz, we can have 3yz squared plus 2x squared z, right? And then minus xy e xyz. And then both of them taking it into the point is 0, 1, 1, right? Because we have the z is 1. So we have x, y, z. So both plug in into these two equations, and we have 1 over 3. But if you would like to directly derive, like for example, if I take the like that, and then we directly gives derivatives dou x. So we are directly derive x, implicitly derive z, and treat y as a constant. So that's how it goes. So now we have 3yz squared dou z dou x, okay, and then plus we have a product rule, so it's a little bit complicated here. Product rule, that is 2xc squared plus 2x squared c dou z dou x, and then equal we also have a rule here to derive with respect to x, e x y z yz plus e x y z xy dou z dou x. And then simplify through the take the 0, 1, 1. So all x will be 0. and then simplified, this is becoming 1, right? This is becoming 1, so this will be dou z dou x is 1 over 3. Okay, same answer. You can directly use implicit or using this formulations here. It's also implicit formula in function of two variables. Okay. Number 4. Perhaps number 4, I would like to maybe write in the blank page. Let me give you another questions here for number 4. Maximum value. The answer is not really in a perfect round numbers. I think it has some square root something. The answer. So the case is we have this function f, right? And we have another one. So in maximum minimum value, if we have a function that we are going to optimize, so this is the one that we are going to optimize, right? And this plane z equal 1 that intersect with the sphere is the one that has the constraint. So we are going to have a limit number here, right? So our equation that's going to be optimized will be limited by this intersection. Right? So we could take x squared plus y squared plus 1 equal 10, okay, so for intersection, and x squared plus y squared is equal 9. Okay. Or we could write take g, okay, as our x squared plus y squared minus 9. Okay. And the one that we are going to optimize in plane z equal 1. So let fxy and 1 become x squared y plus 1. Okay. So we have these two functions. The first one is the optimized one, the one that we are going to optimizations or minimum maximum. The other one is a constraint. You can directly use the Lagrange multipliers. You can directly use the Lagrange multiplier, which is the gradient f is equal to some lambda multiplied with the gradient factor of g. So the gradient vector is supposed to be 2xy and x squared, right? It's supposed to be a factor. And lambda, the g is 2x and 2y, right? Now, if we see the g when it has 0, it's supposed to be negative 9, right? Now, if we let our equation here, so we have a case where we can imagine if this is x is 0 and lambda is not 0, what will happen? It contradicts the constraint, which is negative 9. So we look on another case. So the second case, let x may be 0 and lambda is also 0. So when we have this, we will have the y is based on the constraint. This will be plus minus 3, right? And if we take the f plus minus 3, sorry, 0, and then plus minus 3, and then 1. This is supposed to be 1, right? If we check through our equations. So 0, yeah, okay. And then another case is if x is not 0. If x is not 0, or maybe to make it more clear, let me write into a line equation here. 2xy equal lambda 2x. Then x squared equal lambda 2y. So you will see uh, the formulations from or the possibility of the x and y from these two equations. Okay, so this is first equation. Okay, the third case, x is not 0. Okay. So we can cancel this 2, right? So y is equal lambda. And because y is equal lambda, then x squared or lambda squared, 2 lambda squared is equal x squared. And this will imply the lambda is plus minus square root of 3. If we solve, okay. So if we solve through the circle, the G. So if we solve this, so this is lambda squared, 2 lambda squared plus 9 lambda squared is 3, so lambda is plus minus from here. Okay? So lambda is plus minus square root of 3. And then we check for the positive or for directly square root of 3. We check the f x y z is x squared yz plus 1. So we could have f x is plus minus square root of 6, square root of 3, and 1, right? Okay. So 6 square root of 3 plus 1. 6 square root of 3 plus 1. Okay. And then 4 negative square root of 3. This will be plus minus square root of 6 minus square root of 3 and 1. So this will be 6 negative 6 square root of 3 plus 1. So from here, the maximum value that we have is this. This will be the maximum value. So basically, in Lagrange multipliers, although it seems a little bit having uh, some statements, some options, but basically what we have is we are going to solve and finding which points that is a maximum or which point is a minimum. Okay, and how to find the point? First is we define the one that we are going to optimize. We are going to find the maximum minimum, and we are having another function that is these three cases is the cases that might happen because when you have this, okay, you have these two equations. Let me just write more clear way. the point can be anywhere, right? The point can be anywhere, and the point when x is 0, it becomes troublesome for these equations. This equation might not be okay if we have this x equals 0. So if we have this x equals 0, we need to check whether x equals 0 is in our options in answer or not. Okay? Because we have, if we just assume that we can uh, just skip all this case and directly just write, okay, I will just assume that x is not 0, then we can solve this, right? We can solve this, and we see that y is lambda, and then through this y is lambda, we can have these two equations that we can solve through our constraint. Okay? Constraint is x squared plus y squared equal 9. Okay? We can solve this. Okay? Of course, it's directly going to have the same answer, but what this case means is to show that x equals 0 might change the relations to the function. So if we take the x equals 0, if you take x equals 0, then this becomes 0, this becomes 0. It's not, it's meaningless, right? It's meaningless. So that's why I mentioned these cases, so that we know which part that we are going to have our points in. Okay. And of course, if x 0, how about lambda? Lambda can be 0, and lambda also cannot be 0 also. So which one? And we need to make separate cases. Okay. So these two cases makes the contradiction. So that's why the cases where x is not 0 is the best case that we have to make our functions optimized. Okay. Because the second case, maybe just the first case that is contradiction. The second case is possible. X is 0, lambda is 0, and of course when lambda is 0, then you can just see that because we have the x squared plus y squared equal 9, then this is what will happen if you have the second case here. You will have directly plus minus 3 from the 9, square root of 9. Okay. And of course, 1 is another another value that we can also think, is it maximum or minimum? It just what kind of so 0 plus minus 3 and 1 is also one of the point. But since 1 is not included in whether it's maximum or minimum, maybe it's in the middle, so we can just say that 1 is a possible value from some points in the function itself. Okay. But anyway, usually this is coming from here. Okay. This is from where the case is when x is equal 0. Okay. And this is the first case, x equals 0. And when x equals 0 and lambda is not 0, this will have this contradictions. Okay. Since this is not 0, so y is 0. Okay. I forgot to write the y to make it clear. But for most of the case, if you just skip these two cases and just take into the third case, this one, the last case, I think still okay, because most of the case, Lagrange multipliers will just use the last case. Okay? And then you can solve this equations, okay, between the f and g, solve lambda, okay, and then find the relations between these two functions, and then you can whether you can directly get the points or you can get the lambda and then you put the lambda to make a point. To make a point, it's also the same. So if you want to skip these two, okay, skip the first two, that's okay. Sometimes, most of the case, the Lagrange multiplier just deal with the last case. Okay, this is just to show you the first two cases is also possible. The first two cases is also possible to have, and the first one is actually a contradiction. The second one is possible to have. Okay. Okay, let me give you another question. Okay, any other questions? Okay, I think we can move to next one. I think next one is not too difficult. Number 4 and number 5. Okay, you can try number 4 first, and maybe you can write your answer in the chat box for number 4. Suppose not too difficult because it's a constant. It's having a constant region. And after you finish number 4, you can go to number 5. And if you finish also number 4, please write in the chat box the answer. Okay. Anyone has the answer? Number 4, number 5. Okay, maybe wait for a few minutes. Okay, anyone got the answer? Number 4 and 5? Number 4. Oh, C. Yeah, C, correct. Wait. Yeah. Okay, how about 5? Is there anyone got 5? For number 4, okay, so if you see from the subject, okay, x is from 0 to 1 over 4, and y is from 1 over 4 to half, okay. And what we can do from here is we can, if you look on the questions, the function inside the double integral, we have sine pi x, right? And we have cos pi y. In a sense, these two functions is groups by x and y, and by the theorems that we have in the double integral, we can integrate separately, right? We can separate this. So we can take sine pi x dx and then cosine pi y dy. Okay, and sine pi x is 0 to 1 over 4. This is 1 over 4 to 1 over 2. So this will be resulting uh, cosine px negative divided by pi from 0 to 1 over 4. Cosine will be sine pi y over pi, sorry, from 1 over 4 to 1 over 2. Okay, and then we put on the 1 over 4 inside, so it's becoming cos pi. So this is supposed to be, let me just write the direct results. So this is 1 over pi squared. This is 1 over square root of 2 minus 1. Cos pi over 4 is 1 over square root of 2 minus 1. Okay. The pi squared is from pi and pi. Okay. And then sine pi over 2 is 1 minus 1 over 4 is 1 over square root of 2. And we have solve this to, this will be 1 over 2 pi squared, and then switch the order, becomes 3 minus 2 square root of 2. Okay. So it's going to be C. Okay. Any question number 4? I think it's not too complicated, right? Not too complicated. Okay, and move on to number 5. Okay, what is number 5? So you have a function f, okay, and s uh, is made up from z, right? The surface z, okay, so that is s, and then there's a point on the surface, and it's also having a curve. Okay, so I hope you understand what's the point uh, in the in this question. Okay, you have a curve, okay, two curve, okay, that is on the surface s, and then it's asking partial derivative of x. You should remember what's the definition by partial derivative. Okay. So first is you need to know that we have the point here, and we have another parametric, right? T and u. Now first is to find t and u, okay, through the point. Okay. So we would like to have a 2, 1, and 3 in the curves. Okay. So what will be, and that is uh, when we find the parametric t and u, and then after that we can find the derivative from these two curves. After we find the derivatives, we're going to find the normal vector. And why we need to find the normal vector? That is for the plane. Okay, if you remember the connections between the curves and the plane. And the plane itself is made up from partial x and partial y, and then from there we can find the partial x. I hope you can understand my explanations from there. So first, finding the relations between the point and the parametric, okay, the parameter. And when you find the parameter, and that is where you are going to differentiate. Okay, if you finish number 5, you can write your answer in the chat box. Maybe give you more minutes to check out. Anyone? Or do you still confused on the questions? Okay, so let me give you some some clue. Okay? So firstly, we are having a point. Okay, we are having a point P. Okay, we also have the curve. Okay, so firstly, to make out this point and the curve, we need to determine at which t, so at which t and u that p is on the curves gamma 1 and gamma 2. Okay, so we are going to look on the p is 2, 1, and 3. For the curves 1, we have 2 plus 3t, 2, 1 plus 8t minus t squared. You have 1 here, right? And then you have 3 minus 4t and t squared. So you can see that when t is equal 0, the point is on the curve, right? So when t, so let me write here. So when t is equal 0, this is going to be 2, 1, and 3. The position of the vectors is on the point P, which means t equals 0 is important for us, okay, to make out with the point P. Okay. Now the second curve, okay, we have 1 plus u squared, 2u cubed minus 1, 2u plus 1. If we take 0, it doesn't connect, right? But if we take u equal 1, okay, let's take u equal 1. 1 plus 1, 2 minus 1, 2 plus 1. So it's 2, 1, and 3. So when u is equal 1, it's perfectly aligned with the point P. Okay. So the parameter u equal 1 also important for the second curve. Okay. So at least we get the parameter that we need to make out the curve so that the curves align with the point P. Okay, that's the first one. The second one, okay, so if we imagine, okay, what it looks like, let me just take this as, okay, just to make you remember what we have before in the chapter 14. Let's say this is the curve 1, right? And this is the curves 2. Let's say just that's our curves. Okay? Now, of course, we are going to have some derivative, right? Well, it's not really aligned with the x and y like this, okay? But just to make illustrations, okay? But whatever curves 1 and 2 might look like, if we take this derivative, okay, for the curves 1 and curves 2, and if we take cross product from here, we will get a normal vector, right? We will get a normal vector. And this normal vector is actually our so from the normal vector, we can make out the plane, right? Plane equations, right? Okay. So this will be the first derivative, the first derivative of the curves 2. We take the cross product to make the normal vector, and the normal vector is the one that we are going to need to make out the plane equation. Okay. Now the plane equation itself is basically our partial, right? Okay. Because the plane equation is partial x minus x0, right? Plus partial y minus y0, right? Okay. And this is z minus z0. And if we look at the question itself, it's asking partial x to 1. Partial x to 1 is what we have here, right? Okay? I hope you get the idea. B, yeah, B. Yeah, correct, B. Okay? So, uh, although it, like, you have the surface, blah, 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 it seems that the question is asking the partial derivative, and you remember the concept from the partial derivatives one, right? But actually, partial derivatives can be found on the tangent plane, right? The tangent plane here, from this one. So, basically, what we are going to do is, after we find the parameter, okay, 0 and 1, next thing we have need to calculate is, first is calculate the derivative. Okay, this become 3, 8 minus 2t, right? And 3 minus sorry, not 3 minus 4 plus 2t. And then when it is 0, as we can see that at this point, this is 3, 8, negative 4. Okay? And then the second curves, take the derivatives. This will be 2u, 6u, and 2. And then take it when it's equal 1. This is 2, 6, and 2. Okay? And then take the cross product. So 16 minus 24 is 40, right? 40. And then 6 minus 8 is it's 14, but it's supposed to be negative, sorry. Negative 14. 14. And 18 minus 16 is 2. This is from the here, right? And from here. Yeah, I hope you get the cross product. Okay? What I just skipped some process to just directly write the result here. Okay, now from here we get as this will turns out to be 40x minus 14y plus 2z, or 40x minus 2, right? 2, 1, 3. 2 minus 14y minus 1 plus 2z minus 3. So 40x minus 14y plus 2z equal 80 minus 6 is 74. 66, right? 66 plus 6 is 72. So this is 72. Okay. We can solve. Solve the equations through 2z is negative 40x plus 14y plus 72, right? So z is negative 20x plus something 7y plus 36. And from here, this is the equations for the surface. So this equation is z minus z0 partial x minus x0 plus partial 1. So this is partial x to 1 is negative 20. So this is the answer. Well, if you answer like negative 40, you need to remember that the surface, it needs to be in a z equals something. Okay, so please be aware of that. Okay. 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 Any questions from here? Okay, if there's no questions, we can move to number 14. This is the last one here, and after that we can look up another questions. The So for this kind of questions, it will have a multiple answers. Sometimes it has multiple answers. Okay? Okay, anyone have any idea for the this function? Whether the statements are true? Well, it might be multiple answers, and in your final exam, I will uh, prepare this kind of questions. I mean, there will be some questions that has multiple answers. So maybe giving you a few more minutes. Okay, please try. Okay, please try. C, yeah, but it has multiple answers, so it's supposed to be more than one answer. C is correct. And other any other options that are true? And also, I mentioned that. Did I mention about the adjustment score for our grading system? Yeah, we will have some adjustment. So your final exam, instead of 30%, we need to adjust the scoring system and make it for final exam will be around 23% or 20, yeah, 23 to 25%. And the 5% will be distributed to midterm and the offline quiz. The first thing is whenever you find any piecewise defined functions in function of two variables, and if it is asking about the continuity, the first thing that comes to mind is use the limit, right? Use the limit. Okay. And of course, if it's asking the partial definitions, then you need to use the limit in the limit definition for the partials. Okay. And it's also true for the definition in directional derivatives too. So you need also to use the limit definitions. Okay. Usually, it is obvious when you have uh, the piecewise defined functions for function of two variables. Okay, this is really a clue. Okay, really a clue. Okay, and some obvious reasons to use limit. Okay, any other A and C? Is it continue? Is it continue? So to find whether it's continue or not, we need to equaling definitions in the limit and the function itself, right? Whenever you find one possible things that is discontinued, then it becomes, or the limit is doesn't exist, then it's become discontinued. Okay, I think I will just give you uh, some some steps to first is to analyze and observe. Okay, so first is if we want to take whether the function is continue or not at 0, 0, first we need to make out the limit, okay, as xy approaching 0, 0. Okay, so we take the xy cube. Okay, first consider the path, okay, the path that we are going through. Because remember, when we are constructing the limit, we are going to make several path, okay, options that we are having. Okay, so if you remember, we can if we have, let's say the point is here, we can approach from anywhere we have, right? Which means that we can have, for example, if we take the x equals 0 and uh, let's say we have two paths. Okay, let's say we have two paths. Path 1 is when x is equal 0, and path 2 is when x is equal, let's say, y cubed. Okay. Why I take y cubed? Because it's going to, if we take the square, it will give you 6, which is in our equations, right? And I think it's easy to calculate. So this will give you limit, okay, y equals 0, and change the x equal y cubed. So x y cubed becomes y cubed y6, and then this gives you y6 plus y6, or 1 over 2, right? And then for x0, we can take the 0y, right? So for x0, we see that since the top equation is this xy cubed, it will be 0, so the whole thing becomes 0. Okay. So the whole thing becomes 0. So we can take this the limit is 0. So limit is 0. And since it's not equal, we could say that limit doesn't exist. And f is discontinue at 0, 0. Okay? So remember, when you deal with the limit at the function of two variables, the first thing that you are going to observe is you need to construct the path. Okay? You need to observe each path. You need to make sure that all possibility is they have all possibility, and all options need to be equal. Okay? When you are having one possibility that is not equal with the other one, then it's become discontinued. Okay? So f is discontinuous, so it's not continuous, right? Option A is false. But we have option B, whether the partial x at 0, 0 is equal with partial y at 0, 0, and it's equal 0, whether it's true or not. Again, we are going to take the definitions. We're going to take definitions. So take the definitions, and we will write in the light blue. That is, if we have the partial x at 0, 0, this is limit, okay, x equals approaching 0. This is x. Take this definitions. So we take x, okay, we take x and y is 0. So it's become 0. So it's become 0. And f0, 0 is 0 from here, from the definition from piecewise. So this will be limit 0 over x. It's 0. And partial y, this is going to be y, going to be 0. And again, it's, I think, pretty much similar because we have this top equation that make out a 0, right? Make out 0 when we approach 0. So 0, 0 over 1, this is also 0. So that's true. So it's actually true. Okay, it's actually true, okay, based on the limit definition. And for the points that is not 0, 0, we could take the partial x, okay, as the definitions. We could take the definitions through the definitions for the partial x is supposed to be this is x. Let me just change FAB. So AB cubed divided by A squared plus B6. Okay. And then A squared plus B6. A squared plus B6 minus, this is A squared plus B6. Oh, wait. I believe this is supposed to be I think we can write directly. A b cubed a squared plus b6. Let me check this one. A squared plus b6 wait. Yeah, I think it's correct, right? Partial x, right? And we can solve this for a squared plus b6 squared, and then take out the 2a cubed b6 minus a squared. A squared minus 2a squared, yeah, minus a squared. And whenever you find a differentiable, if it is already discontinuous, so it's not differentiable because discontinuity. Okay. This is correct, right? Using the quotient rule, right? Okay. So that's how it is. Maybe maybe two more questions, and then let me just explain what you need to prepare for the finals. Okay, wait. Any questions? If you have any questions, you can write in the chat box. Okay, wait for a minute. I will transfer it quickly. Okay, let me continue. Okay, is that okay? Any questions from number 14? Okay, so please do remember you have for partial x, partial y, and also for the limit. Remember for the limit you need to construct a path. For the partial derivative you have limit definitions, and also for directional derivative you also have limit definitions. Okay. Um, Maybe we can start with this change of variables. I think because we already learned before at the last section of the chapter 15, I believe you should be able to solve this, okay? And we also have this. Maybe concentrate for the second one. Okay, the first one, we can tackle that if we have time. But let me just show you this second one. Now the second one here, it's a we have a solid. Uh, the solid is above the cone, so we have a cone as in the picture. We have a cone, and so lies above the cone and below the sphere. So first is this is the sphere, right? The red color here. Right? And then you have the cone. The cone is here. Okay. And it's given the angle. This angle here is pi over 3. Okay, let me give you some times to think and then try to find. It's a little bit complicated, right? Okay, I think for number 4, easy to say that if we let the y minus x and y plus x as our change of variable, let's say we have this u and phi, then we can make out the another formulations for points u phi. So y minus x is u, so 2 and 2, right? And then this becomes 0 and 2. This is 0 and 4. And this is negative 2. Oh, sorry, 2 and 4. So u is from 2 to 0 to 2, and v is from 2 to 4. And since it's another square, then we can just find through the we could make out into, let's say we have 0, 2, and 2, 4. U over phi, and then the Jacobian, check the Jacobian, and this will be d phi, and you can solve, okay? For this one, it's a little bit complicated. It's a little bit complicated. Do I have another questions? Wait. Yeah, maybe I give you another one, okay? We're pending number 5. Okay, if you want, you can try at your home. Okay, maybe this. Okay, this one. Which value of the following formula is different from the others? Well, you need to try one by one. Okay, try one by one. First is take out the inside integral, right, for each cases. So you could take all the integrations. And I think this is not difficult for this one. Yeah, for the second one here, this sphere, a little bit complicated. You need to use this, utilize the cone. Okay, cone. Cone is 1/3 area and height, right? So you need to find the height, the radius here for the cone. Okay. But I think before we end this one, okay, you can try at home. Okay. Let me explain a little bit. Okay, let me explain a little bit for your final exam. Just announce that for final exam we will have two sections. Okay, section 1, section 2. This is quizzes. This is the flexi quiz, the one that you are now have as a quiz. Okay, for the quiz chapter 14, okay, using also the flexi quiz. So for flexi quiz, use a private browser. Okay, use private browser, and then there will be part A, part B, part C. Okay, please read the instruction. Okay, please read the instruction. For part C, you could prepare a paperwork and send an email. Okay, later send an email. I write all the instructions in the platform, so you just read all and uh, later after finish the finals, send an email. Your quiz chapter 14 also the same. Okay, please read all the instructions. I prepare um, some welcoming message, and don't forget to send me an email. Okay? And then we are going to take the final exam. So we are going to have an online WebEx. Okay, please on cam. Okay, so after you enter the meeting room, please turn on your camera. Okay, uh, it's open notes. Okay? You can prepare books, notes, anything. Okay, if you have a lot of devices that you're going to use, it's okay. Okay. Calculator, fine. You can use also. But you need to work alone. Okay, work alone. Okay. So I hope I give you this freedom, and I do appreciate that you are working on your own. Okay, not working with your friends. I really do appreciate if you working alone. Okay. If somehow I found out, then you will fail directly the finals. Okay, if I find out, and usually I will know. Okay, I will know. And what else? The chapter for final exam, as I mentioned, chapter 12, 13. This will be minor subject. And then we have a chapter 14, 15. So we will have all majority cases from 14 and 15. So from the limit, continuity, right? And then the partial derivative, the tangent plane, the directional derivative, chain rule, maximum, minimum, the Lagrange. 15, the double integral, polar, surface area, triple integral, cylindrical, spherical, the Jacobian. All will be in our subject, except that the one that we skipped. So the one that we skip in the 15, we have the mass and lamina, the density that we skip. And yeah, I think for 14, there's nothing all. So 15 skipping the mass and lamina. Okay. Maybe any questions first? Okay, any question first? Oh, by the way, and the finals, I prepared some questions that if you take the wrong answer, your points will be get some deductions. So please read the instruction carefully. Okay? So any questions regarding the final exam? Yeah, don't be sad. Alice and Elephant, because the deduction and the point that you will get, it will be adjusted, so should be should be okay. Okay. Any questions? Any questions? Palis, you raise your hand.
Actually, professors, I have questions about the quiz.
Mm-hmm.
I wonder, like, is it possible that you extend the deadline maybe like to midnight since I am certain that some of us have like three midterm exams tomorrow already.
Oh, uh, the quiz is until Wednesday.
Yes, but maybe like maybe if you extend a bit like maybe to midnight or
Oh, okay. I will adjust the time. Okay.
okay, thank you, professor. That's
Okay.
maybe like provide a little more time for us. Thank
Okay.
you.
Okay. Yeah, for this question, any part we need to write down the process and take photos. Yes, the part C, you need to write down the process for part C. Okay, so paperwork. Okay, so write in a paper. You can scan photo, and send to my email. And you need to do all this process according to my instructions. Okay? When you have some fault in those uh, process, or maybe not writing the name of the files not according to my instructions, maybe also another deductions. Okay, so please read carefully, read the instructions. Okay, if you follow the instructions, it will be okay, right? Okay, any other questions? If not, then we finish. Okay, we finish. uh, we finish. And if you have any questions later on, you find in the textbook the exercise that you feel that you need to have a discussion with me, you just email me. Okay, just email. Okay, then this will be last lecture. Okay. Um, Hopefully you can work and study, okay, for final exam preparations.